Hello, my name is Neville Palmer, and I'm going to talk about a multi-platform assessment automation application for practical outcomes in computer network systems. So the background to this is that we are teaching computer networking, which is an engineering related discipline. We need to teach both theory and practice. We need to look at real world skills, and these are important for employability. We obviously need to look at developing a laboratory, so it's important that we have laboratory exercises, and we also need to manage the laboratory. We also need to conduct assessment. Now, the assessment could be in the form of a report, but it could equally be in the form of some kind of practice-based, time-constrained examination. Now, this presentation is based upon previous work. Now, in a computer networking laboratory environment, we might be using virtual machines, using operating systems such as Linux and Windows. We may be using simulators such as Cisco Packet Tracer or GNS3. We may be configuring network devices such as routers and switches, and that may be using real equipment or using simulators. And obviously we need to look at multi-vendor equipment. It might be Cisco or it might be Westmo, which is associated with industrial networking. Now, if we look at assessment, one of the things that we would have to consider is practice-based assessment. So we need to design a practical exercise. Then we need to develop solutions, and we then need to implement this exercise, such as setting up the environment. Then we need to deploy the exercise in the laboratory. Obviously, students come into the laboratory and they complete the work. Then we need to extract the student work, and then the assessor would compare the student work with their known solutions. Obviously, what we can do is we can say successfully completed tasks from the total would give us a result, and that's one way that we could assess it. So we wanted to look at ways in which we could automate some of this work. So we wanted to assess practical outcomes. We might be using network devices and computer operating systems as part of an exercise. This might be within a real or virtual environment. We may need to be doing some configuration management. And obviously at the end of an exercise we might need to read configurations from the environment. We may need to run scripts during and after the assessment. And we need to configure template solutions. We need to define the criteria and what feedback we want to give students for the assessment. And obviously the assessment would be comparing the student work against our known solutions. We want to automate that. We also want to generate feedback. Now, the whole process of automation, we decided to develop an application that we called Network Assessor to automate that configuration management and assessment process. So we developed assessment automation software that we called Network Assessor, and it can also do some configuration management. But what you're seeing here is the main assessment page on the software, within the software. You can see that we're comparing students' work with a known solution template, in this case on this form. And in order to test this application, we used it within a simulator. We used it within the Cisco Packet Tracer simulator, and we developed a simple topology as part of a practical exercise that students could perform. Now, we ran the exercise within the Packet Tracer network simulator, and now Packet Tracer has got its own assessment automation built in, so we're able to use that. And we also took the configuration files from the simulator, and we used the Network Assessor, the new application, to also assess the same exercise. And you can see that we compared the results of the two, and we found there was a good correlation between the Packet Tracer results and those of the new application. In fact, the new application rewarded some tasks that Packet Tracer incorrectly marked as wrong, the new application marked them correctly. The reason for this was because students might use a different name for a variable, such as an access control list. They may use their own name instead of the one given in the text. And while the syntax they used was still correct, so the configuration that they did was still correct, and therefore it should be marked as correct. But of course, because Packet Tracer was looking for an exact match to the name, it didn't mark it as correct. So the new application did actually take into account variations in student naming. So you could make the exercise less specific, in fact, if you're using the new application to do the assessment. Now, this test had been used within a simulation environment, the Packet Tracer, but we wanted to also test the software because it was designed to be used in simulators or real systems. And so we decided that the next test would be a real system test using a non-simulator. And we decided to use a real operating system, Windows and Linux. These were virtualized but not simulated. And we decided to use two operating systems because this is supposed to be a multi-vendor application. And we actually used two flavors of Linux. So we looked at the domain name service. We wanted to look at a service that we could use that could be configured in three operating systems. That's Ubuntu, CentOS, and Windows Server. So we looked at domain name service because it's an open standard using the request for comments. It's interoperable between the systems. And that became the basis of our exercise, that we were going to use the new Network Assessor software to test its functionality. Now, a DNS zone file it shares a common format, more or less the same format between Linux and Windows, and this is what a zone file might look like in either of those operating systems. But in Linux, we need to also take into account that when you install the bind or DNS service in Linux, that a named.conf.local file is configured, but you have to add a pointer record to the actual zone file, to the DNS zone file in that named.conf.local file. That you don't have to do in Windows. So there's a slightly different configuration between the three different operating systems. That's Ubuntu, CentOS, and Windows. We need to take that into account. So we had some additional application requirements. We had to modify the application to take into account those additional requirements. So first of all, we needed to locate a configuration file. In this case, it was the DNS zone file. And also in the case of Linux, we also needed the additional feature that we needed to locate the named.conf.local, for example, and define the zone file, the pointer to the zone file within that. Then we need to locate items within the configuration file. And in this case, that would be a host record, a DNS host record. We also wanted to conduct live tests. So we want to check to see whether a service or process was running. In this case, it's named in Linux and dns.exe in Windows, for example. We also wanted to conduct additional tests. So in this case, it might be doing an NS lookup to check for a host record, and that would also test to see whether our DNS server is working correctly. So we added the additional features to the application, and that took the form of an additional form on one of the tabs in the application. And that tab had to locate the configuration files. And in this case, it was locating, in this particular example, locating the Linux DNS or bind zone file. And another form ran the live tests. In this case, it was checking to see whether the named daemon was running, and also using NS lookup to locate a host record with the running DNS server. and the results of that were output to a text file. Now in this text file you can see that it's showing the results that it's found the zone file. It's also found a host within the zone file. It's also saying that the named process is running, and also the NSLOOKUP has returned a host. So this is a text file that we can see whether the system has been configured correctly. So in conclusion, we've seen that the modifications to the application will work with real operating systems. So that's 2 distributions of Linux and Windows Server, so that we can see this is a multi-platform application and it performs according to its requirements. So future tests might use an exercise involving real equipment, which may be Cisco, but perhaps with other vendors as well, to show that it's truly multi-vendor. Now we've already looked at an exercise involving a network topology, but that was using a simulator. But this exercise used operating systems. And whilst the output was in the form of a text file that the assessor, the tutor, could look at to see whether the student had correctly configured a service such as DNS, there's no automated assessment. It doesn't sort of give you a grade, for example. But we could use that text file as a template solution, and as I showed you on slide 6, we could feed that into the assessment automation features of the application, and we could then take the output of student work from the exercise and compare it with the template to provide an overall assessment. Now it's also possible that we can import the results into another assessment application, and another assessment application has been developed which enables output in the form of a rubric with feedback and a grade. And it's possible that we could take the output of this application, the network assessor, and feed it into that application to provide something with more meaningful feedback and a grade to students in a format that they are more familiar with. And these are the references, and thank you for listening, and if you have any questions.